Hi guys, today we will be performing a multiple linear regression on a data set, and we will be including the interaction terms to see how they affect our model fit. So first of all, we're going to load the library. Let's run that. We're loading the library read Excel in order to be able to read the Excel files. Okay, let's load our data set. So it's going to be employee. We're going to name our data set employee, and we're using the function read underscore Excel. And our file is named as employees.xlsx. Make sure that the file employees.xlsx is in the current directory, the directory that you're working in. Let's run that. So as you can see on the right, on our global environment, the employee data set has been loaded. Let's have a look at our data set. So we're going to run str employee. That gives us a bit of information about the variables in our data set. So as you can see, we have three different variables. So years of experience, salary, and level of employee. So years of experience is the number of years of experience an individual has. So that goes from 1, 2, 3, 4 like that. And the salary is the amount of salary into Ks, into thousands of dollars. So for example, if you have 50.8, so that means the salary is $50,800 per year per annum. And the level of employee is what level of job the individual has in the organization. So for the level of employee, we have management, general staff, and technical staff. Look into that further. Let's run the summary function on employee. So as you can see that again we have three columns, three variables: years of experience, salary, and level of employee. But the level of employee is considered as a character variable, but we don't want that. We want the level of employee to be considered as a factor variable with three different factors. So let's convert the level of employee variable into factors. So we are going to take the employee dollar level of employee. So we're taking the variable level of employee from our employee data set, and we're running the as.factor function to convert it into factors. Let's run that. Okay. So now again, let's run the summary to see what, if anything, has changed. So as you can see, the years of experience and salary remained the same, but level of employee changed into three different factors: general staff, management, and technical staff. And each of them has 40 variables, 40 observations, sorry. Now, what we're going to do is we are going to fit a multiple linear regression model with salary as our dependent variable and years of experience and level of employee as our dependent variables. But this time, what we're going to do is we're going to include the interaction terms. Okay, so let's fit that. So we're using the LM function, salary, years of experience, and in order to include the interaction terms, we're using the times operator, times level years of experience times level of employee, and the data comes from employee data set, and we're naming our model LMCAT. Let's run that. Okay, let's see how good our model is. So we're going to run the summary command. From the summary command, if we look at the residuals, we can see that the residuals are normally distributed with the range very similar. The median is around 0, which is good. And if you look at the intercept, the estimated intercept is 20.19858. Here the intercept means the salary when everything else is 0. So years of experience is 0 and level of employment is also not considered. So everything not considered, the salary is 20.19858. In this case, I don't think it makes any sense to have any salary when everything else is 0. But the model estimates the intercept to be 20.19858. And as you can see, the p-value for all of the variables is less than 0.05. All of the terms, all of the beta, all of the, you can say the slopes or the intercept is less than 0.05. So we can say that all of the terms here, all of the intercepts and the slopes are significant in our model. Now, if you look at the multiple r squared, it says 0.9951, which is very good. That means our model um, that 99.5% of the variance in salary is explained by the years of experience and level of employees. Sorry. Okay, so that's a very good fit to our data set. Um, let's have let's look at the residual plots to see to again confirm the goodness of fit of our model. So we're gonna run the we're going to look at the data sets. We're going to look at the residual plots. So as you can see that the residual plots look very normal, looks very good. So for the first plot, if you can see residual versus fitted, the residuals are very scattered around the zero line, around the horizontal line, the red line there. That means the residuals don't have any pattern, don't follow any pattern. So that means uh, our model is a good fit to our data set. If you look at the normal QQ plot, which is trying to estimate if our residual is distributed normally, which from the plot we can see that it follows the straight line, it approximately follows the straight line. So that means our epsilon, our residual, is in fact approximately normal with mean zero and standard deviation sigma. Standard deviation, sorry, 1. Okay, and scale location, again, this is scattered, and the red line in the middle looks very horizontal, so that's also good. And the residuals versus leverage, the fourth plot, this also looks good. We don't see the red line deviating much. So it means that our residual analysis, residual plots confirm that our model is a good fit to our data set. Okay, let's minimize that. All right, so we'll put it back so that param pro C11, so we have one plot at a time. Now, next thing we're going to do is, as you can see, our model gives us our LM function here, LMCAT model, gives us just one single model for all the variables. But we don't. Let's see if we can create fit three different regression models for each level of employee. So we're going to fit a regression model for the technical staff, technical staff level of employee, the management level of employee, and the general staff level of employee. So in order to do that, we are going to convert our level of employees as numerics. So what it's going to do is it's going to give a number to, let's say, technical staff is going to be, let's say general staff is going to be 1, management is going to be 2, and technical staff is going to be 2. Okay, so let's run that. We're going to do PCH. Okay, and then we're going to plot the years of experience on the x-axis and salary on the y-axis to see the relationship between salary and years of experience according to the level of employee. Let's run that. And just let's put the legend there. So as you can see that as years of experience increases, salary also increases for all three of the different level of employees. So here you have the dots, which is represented by the general staff, and the technical staff here represented by plus, the management staff here represented by a triangle. So as you can see, all three of them can be approximated by a straight line. Okay, let's figure out the equation of the best fit lines for all three of the different regression models. So in order to do that, we're going to get the coefficients first. Let's look at the coefficients. Okay, so it gives an intercept, years of experience, level of employee management, level of employee technical staff. This is the interaction term between years of experience and level of employee management. And this is the interaction term for years of experience and level of employee technical staff. Okay, so let's calculate the intercept and the slope for the regression line for the level of employee of general staff. So we're going to name it employee general staff, and we're taking the intercept plus intercept, and this is the intercept. The intercept is going to be 20.19 85769, and the coefficient is going to be years of experience. So 0.25060. So let's run that. Okay, and let's figure out the intercept and the slope for employee level of employee of management. And the intercept for that is going to be 20.1985769 plus the 30.224726982. Okay, and the slope here, it's going to be the years of experience slope plus the interaction term for the management staff. So for management and the years of experience. So that's going to be 0.2506060, 0 point plus 0.4875600. Okay, let's run that. And technical staff, for the technical staff, the intercept is going to be the 20.1985769 plus the level of employee technical staff, that's 10.3687308, and the slope is going to be years of experience plus the interaction term between years of experience and technical staff. So that's going to be 0.2374522. Okay, let's run that. All right, now we have the intercept and the slope for all the regression lines for all three of the different level of employees. So general staff, management, and technical staff. Let's fit the best fit lines to our plot here. So first we're going to plot the best fit line for general staff. Remember, general staff in this graph is the circles here. Let's run that. So as you can see, for the general staff, the dots are very closely follow the red line here. So that means that the thing that we previously found, that our model is a very good fit to our data set. This is confirmed by the straight line. The straight line is a very good fit to our general staff employees. Okay, let's run the same thing for management. And as you can see, the management is the same thing. The circles, the pyramids, follow closely the blue line. So that means it's a very good fit. Let's run it for the technical staff. So again, for the technical staff, you can see it's the same thing. The data points follow the best fit line very closely. So that means that for all three models, for all three employee levels, the linear regression model that we created is a very good representation of our data. And this confirms our previous finding that the 99.5% of the variance in salary is described by the years of experience and the level of employee. Okay, so that's the model. Thank you guys so much for watching my video. If you like my videos, please like and subscribe, and I will see you guys in the next video.